So, in this question, which is, as you can see, question 18 in the final review in My Open Math, they ask us to list the possible rational zeros of x to the fifth minus 10 to the x to the fourth of this um, expression here. Now, why are we doing this? Why do we want to? Why are we interested in the rational zeros? Well, let's say that this was an equation, not just an expression. X to the fifth minus 10x to the fourth plus 3x cubed minus 2x squared plus 6x minus 4 equals 0. And we want to solve for x. We want to find the zeros of x. We want to find the roots. Now, it's pretty hard to solve an equation with a degree that's 5. It's a big exponent. But we can actually, with this magical method of the rational zeros, we can find some candidates for the solutions. We can find some possible zeros. Then we have to try them out later to see if they work. But the way we find the possible rational zeros, you take the constant term, the coefficient, I'll just say abbreviate coefficient of the constant term, and we divide it by the coefficient, which by the way is 1, the coefficient of the leading term. And we always use a plus or minus in both of these cases with these numbers. So you see, it really doesn't matter if this is a positive one or a negative one, because we're going to use the plus or minus anyway. It doesn't matter that this is a negative 4. It could be a positive 4. We're going to use plus or minus anyway, both possibilities. Now, this is the ratio of, and by the way, though, I should put all factors. All right, all factors. And the same goes for all factors of the coefficient of the leading term as well. But you see, factors of 1, the only factor of 1 is 1 itself. Or it could be a negative 1 is also a factor, since a negative 1 times a negative 1 gives us 1. At least, well, I'll leave it at that. But 4, the number 4 has 3 possible factors. If you want to factor 4, you can factor it as 4 times 1, 4 times 1, or factor it as 2 times 2. So you see all of these numbers, 2, 1, and 4, are all factors of 4. So that the possible factors of this numerator are plus or minus 1, plus or minus 2, and plus or minus 4. We'll divide that by the plus or minus 1, which are the only factors of 1, of the leading term's coefficient. But that leads to, a lot of possibilities already in itself. I mean, there's the number of possibilities here includes 1 over 1, a negative 1 over 1, 2 over 1, a negative 2 over 1, 4 over 1, a negative 4 over 1. There's 1, 2, 3, 4, 5, 6 possible ways you can combine the coefficient of the constant term, the factors of the coefficient of the constant term, with the factors divided by the factors of the leading term. Now, of course, an easier way to write this down, you don't need to have 1 in the denominator all over the place. That's kind of redundant. So, and we can just write it like this. Plus or minus 1 plus or minus 2 plus or minus 4. In other words, there's 6 possibilities of these combinations of coefficients. And these are the 6 coefficients. When you put that in to MyOpenMath as your answer, you'll like it. That is the answer to this question. List the possible rational zeros of this expression here.